Hello guys, I'm ElfNet Gaming, and back on the bench here with another power supply. This is the Welch Scientific Company power supply. I don't see a model number, but this is a filtered power supply. It's got a catalog number, 2606W. It's got DC output and AC, so this is a variable for AC DC. So circuit breaker, 170 volts, 50-60 cycle. This looks like something that would be on one of the new 9 Inch Nails videos. It's rusty, it's old, and this thing has a problem. It does turn on, it does kind of work, but it doesn't work to specification. Under a small load it gets really hot, and there's hum and audio and radio equipment. So we're gonna go into it. Like I said, it's a dual type. It's got AC and DC. Also, the meter is jammed here, which I think at top just collapsed off of it for some reason. Now this is part of that TV shop haul stuff that I got, where I got the other power supply repaired, some service monitors, a bunch of parts and stuff. So, like I said, it does work and everything like that. It just doesn't work to spec. So, I'm not gonna use it mainstream if it's not, you know, it ain't working right. It's sick. Oh, it's sick. So I'm going to get it down here. Also, I might repaint this thing. Also, the feet. It's missing the feet off of it. So I might try to find some feet for it, because it's going to scratch up everything it touches. Okay, so this looks like it's going to need a 1/4 inch driver, a flathead, which I have. So we'll start getting the screws out of here. So it's got that type of screw. So I'm just going to stick these to a magnet so I don't lose them. We're going to get it open. This might be a multi-part video. Right now I'm just going to open it and assess it. I can already tell you, just by the age of this, excuse me, I can tell you by the age of this that this is going to have selenium rectifiers, and I know that because it's got these screws here on the back. It's a full bridge selenium rectifier, and that's going to allude to why it gets really hot, because it does get really hot back here in the back. And it's probably going to have a paper capacitor, one of those big silver things in it, electrolytics, which I got replacement caps and replacement rectifiers. It's probably going to be very similar to the other ones that I had on the bench in the past, the variable. It's got the choke and all that. So got all the screws out. Take off the top. Over here. Here it is. We got our little selenium here, like I said. Selenium rectifiers on the back. Those are before the days of silicone. And what I need to do here, that's negative, and that's only positive, I think, right there. There's the meter. Okay, we can fix, well, that meter is kind of funky, so I might need to take it all apart. There's the capacitor. This is, what is this? This is AC here, going into this transformer. DC here. I'm in off the capacitor here. So this looks like one side of AC. This may be the other side of AC. Huh. We'll have to ring it out and see. This would be a coarse adjust for the meter. Huh. Oh wow. A circuit breaker. Look at this. Let me just get the camera and we'll dial in on that. Yeah, somebody's already been in this. What is that, solder? That's solder. That's that good old lead solder too. Yeah, that's solder. So the previous owner shorted the circuit breaker because they were overloading it. That might have something to do with why it's not happy. It's got a lot of dust. There's a capacitor. Of course, there's the choke. The variable transformer down in there. This is a terminal block meter. That's our little neon indicator here. Different switches. Use on the back. There's a power resistor right there. So I'm gonna have to trace this out. So I'm gonna cut the video and go to tracing this out with the meter. I'm gonna see where this rectifier is coming out in and doing its thing, and then I'll be back. Okay, so I fixed the needle on this. It's now freed. Well, I'm gonna go through this, probably hot glue these down or super glue these in. These terminals keep wanting to come up, and I noticed that this had screws that someone took out. So, but the needle is moving freely again. Now, I have to be careful with this. And apologies for all the coughing and stuff. I just ate something that was hot. So, excuse me. I won't be doing that again while I'm recording. I need to... Anyway, I gotta be careful with this because I don't even want to know the rarity of this. And there's probably two choices to replacing this. Either one is the one from China that's so cheap that it'll break in a week, or the one in America that costs 10 times more than what it's worth. So I'm going to be careful with this thing when I'm trying to find screws and trying to get it all locked back down. So, alright. Alright, so I'm back. My camera battery died there. It didn't even give me a notice. It just died. Usually it dings at me before it dies. Huh, it's interesting. Maybe the battery's going all the way out on it. I don't know. Anyway, I don't know if it caught or not, but I found a screw for the bridge rectifier, which I'm putting in here. A nut screw with a nut, and I'm going to connect the AC side. Actually, I don't have anything to insulate that, do I? Like, hold on. I don't want that too close to this choke wire right here because, God damn it. Fuck. A lot of crap under my desk right now. It's stabbed me in the leg. So what I'm gonna do here. Well, that's not gonna hurt it. I don't want to be going on all night with this, so I'm just gonna hook this, crimp it, solder it somehow like that. Straight down with it, like, and then just bend it around that way. And I'll get the yellow wire on, and I'll replace this black. I thought about replacing all the wires in, but I'm not going to do that. That's not even necessary. The wires are not cracked or anything. They're a little dry, but they're not in a state to where they're going to break, create problems. Alright, so let's solder here. Make sure we get it all good and on there. Okay. Then we'll put this one on. If I can. Got goofed up here already. J-hook this, kinda, sorta, maybe. Get it in there carefully. There we go. Now, solder it down. What's the worst that could happen? Fire? Back side. Okay. Alright, that takes care of that one. This black one, heat up, get it off of the terminal. That 86 it, and then we'll bring the new black one over here, size it up, cut it, so we'll go right about there, so I'll cut it about here, and I'll strip it, and we'll wrap it on this. On there pretty good, or good enough anyway. Then solder it down. Okay, now the AC terminals are on that side. Okay, this side here, I gotta clean off the enamel so I can tin it and solder it, or it's not gonna stick. Hopefully that's good enough. This little piece. There she goes. And I want to clear this hole if I can right here. Need something to poke through there, like a toothpick maybe. I want to hook these on. I don't want to just stick them in and go off a wing and a prayer. I want them to be on there. So that's dodgy looking. That's real dodgy looking. These, man, that's that's interesting. We need to a little more with it. Whoa. Just bump everything. I have a tripod. I don't know why I'm not using it. Used to the old way, keeping the camera here stuck up on a thing elevated above this bench. I have a tripod and all that, and I don't even use the damn thing. Probably should, though. Probably should. So that's taking care of our AC load. And we'll be on the DC in a minute. That's bound. Okay, that's bound and hooked. And actually it's not, wasn't cooled down yet. Oh, now it's cold. That's nice. Now it's a cold joint. I'll let that sit for a minute. I'm getting ahead of myself. I do have the Dew of Mountain in a 8 of power bottle. There's no alcohol here. Okay, let's bend this around. It's not touching any metal. Okay. Our negative DC. What our negative? Okay, that's got to come off of there. And the choke. Ooh, wait a minute. Didn't I have a white? Okay, that's the meter. That's the meter. Positive. On that. So the choke and off here. So this is positive right here. And then there's a negative that comes off of here as well. So I need another black wire. Or a couple of black wires, maybe. Cut that. I wonder if I could desolder the choke lead. If I could just desolder this, it'd be nice. I have a feeling that it's all wrapped in and it's not gonna. Oh, well, okay. All right. And that's wrapped up on there. They actually did this right here. So I'm just going to cut it out. Okay, now I got to get somehow, just undo it from down here, I guess, and take the whole mounting mechanism out. Capacitor out of it. I already know the cap's bad because it hums. It's a paper cap, and well, you know, paper caps, notorious for failures. So Mallory, type FP. You're probably never going to see this text ever again. Made in USA electronic parts. Okay, so this is a 2500 microfarad 25 volts. Now what I have here, it's a little smaller, but this is an 8200 microfarad at 110 volts. This is well within spec. This right here may actually give it more oomph. And I really don't think that that's gonna work there, so I might need to build up the base of this capacitor. I'm going to use some electrical tape here. I'll just run a band around the bottom to kind of just thicken it up so I can put it back in the holder. It's kind of a waste of tape, but I got more tape now. maybe that'll be enough. I hope that's enough, because I don't want to use any more than I need to here. Off. Yeah, that'll hold it. So that'll hold it. Okay, so we'll tighten it up. Sorry if I'm not in frame. I'm just tightening the brace capacitor holder back onto the deal here. That goes like that. Positive. Where's the positive? Positive's over there. So I'm going to position it kind of this way so I can get to the positive easy. And I'm going to put this brace in the other way around than when I took it out so that the screw is easy to access. Makes more sense this way. Okay, so the ground should go there. So there's like a terminal ground here. And I'm assuming that it's just going to go under that. And we'll kind of screw everything back together if I can. This transformer in this thing is heavy. Okay. Okay, so now we're right on the money. At least on one side. There's the other side. Oh my God. Man, that's squeaky. I'll find some feet here. Oh, I'm bumping them. Okay. Tells you how close the camera is to the bumping the cord to it. Okay. Alright, that's in. But I want to go under this one. This is going to the choke. So what it's needing to do, we got a lot of enamel. And I'm going to tin these too, so they're not. This is the positive here. Well, that's the negative. I could solder these on, but okay, now I'm putting screws on. We want to go this way around. Being really violent with the camera. I'm going to tin this wire up. Make sure it's good and conductive on all sides. Looks good to me. I don't want a heavy layer of solder on it, just enough to coat it. The same with this bare wire here. Just enough to tin it up, make it silver all the way around. Because it's got to conduct. Okay. Now, we can go on and preform these. Take this bolt out right here. That's a long go. I didn't think they were quite that long, but they are. They're long. Okay, so I'm going to put this one on first, the bare one, or the rigid one on first. And we'll, like that, I need to actually get a little more here. In there, and I'll put this one above it. Just wrench it down. You always want to wrap in the direction that the screw is tightening up. If you don't, especially with stranded wire, you'll end up with strands of wire everywhere. And since I'm not really satisfied there, I'm gonna put a little bit of solder on here to kind of well, that ain't gonna work. I gotta take it off. I'm trying to get it more or less on there in a way kind of like that. Actually, I want to put the stranded one on the bottom, I think. How do they think about it? Okay, so in any event, I do want to kind of try to bond these together somehow. I probably should have done that before I went to wrapping. So I'll get some forceps out here. Kind of hold them together like this. Maybe. No. Oh, the fun of electronics, right? I have a career in electronics. You don't have to really do a lot of thinking. I've gotten pretty good at power supply repair, though, over the past few months and years. You don't want to. Oh, I see what's happening. The stranded one wants to separate from the solid one. It gets warm, it wants to not cooperate. Okay, that's warm. Note to self, the solid wire is extremely hot after holding a soldering iron on it. Long time. Ooh. Man, that was rough. That was rough. That was hot. There's an easier way to do this. I could have just wrapped it and called it a day, but I didn't think ahead that far. I had a boss in college told me one time, "You're not getting paid to think." that's minimum wage jobs for you. You don't get paid to think, right? McDonald's or Walmart or something. Factories. You don't get paid to think. Paid to work, to be a mindless zombie. Slave. Okay. Alright, new capacitor, new rectifier, new breaker. All this looks pretty decent. This black wire here, I'm going to have to replace it because it's not long enough to really reach up here. Like I said, I just happen to have more. And I'm actually going to need more than one. I got to get over there and I got to go over there. So I'm going to strip this black one back a little further than normal. And I'm going to just twist these together, just for simplicity. Do it like that. That's what I should have done with this other, but I just wasn't thinking about it. No one's perfect. We're not perfect. I'll solder. Just tin all this up for that good old connection. And then I can actually go and put it on. So I'll get the screw on anyway. Do that whole thing there. Make sure the polarity is correct. It is, of course. Now, one wire is going that way. One wire is going to loop down here. So I'm going to reflow this terminal. And I want to really take the resistor off if I can help it. I just want the wire off. There we go. Just the wire. And I'll strip this. Actually, I'll move out this and gotta cut some off. And we'll strip them. Let's get kinky with the camera once again. And wrap it. Wrap it around the terminal. That's what I'm doing, right? Yeah, that's smart. You can't see through the breaker. I apologize. But I'll go through it all in a minute when I got it all together. Be a little generous with the solder here. All right. Okay, that's on. Push it down like that. Now, positive, we got to get this one sanded. And I'm going to hook it and hook that. And that should be the last of the connections, I hope. And I'll put the meter back in too. Okay. Maybe, I don't know. It looks like it might be good enough to take solder now. Oh, that's hot. That's going to be hot. Don't forget, the solid wire is hot. It's not even turned on this side. We'll fix that. And I could use a cigarette lighter, but I don't want to deal with the soot. Well, that's trying to cool off, so we're going to get this one here prepared. That's coming from that capacitor, and that's going to go to the negative, which is the bottom. Actually, it'd be going to the capacitor. But in any event, still, let's get rough with the camera. Yeah. Keep bumping the camera. Okay, that's the negative on the bottom. Yep. Okay, there's that. Now, I'm gonna kind of bend this around, get it in there, and secure it like that. I guess it's about a 30 amp rectifier, so it should be well within limits of the power supply. That might be a 15. There was no number on it. I can't remember what it is. So, forgive me. Okay, so we're pretty much soldered up now. Now it's left to put the meter back in. And you can see AC coming in here and here. Here. This is your DC positive, DC negative. It's going through a choke under the capacitor here and onto this distribution marshalling board, I guess call it, through this little load deal here, and then off to the positive side of this switch, and then into a resistor, not into a resistor, but it's going down there. It's not going into the switch, it's going down there to that red terminal and back up to a switch and to the meter, blah, 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 blah. Okay. AC is just tapped right off of the transformer, the variable, and going over here. I replaced that wire. I also replaced that black wire down there. Right down there. So all that's left is we're going to put the meter in, and I did free up the movement of the meter, which is good. And, I'll try to get this all back in here. It's got this weird clamp thing going on. Now I got to close it back up. Jeez. Now it's stuck. Anyway, come on, no, there. I'm gonna close the little leaves back in a little bit here so it grabs these leaves here. That way it grabs the plastic when I put it back on. It'll hold it. Move it in place. Like so. It's in there, it's not going nowhere, so now we'll put on the red and we'll put the black back on, and that'll be about it. We'll plug it in and see what it does, and get the voltmeter on it too. We'll check it, make sure we're calibrated, I guess. Well, I got it open. Try to fix these damn lugs back around so they... That's really weird. Anyway, okay, let's Okay, power's off. Power's off. I'm gonna put it in the isolated plug over here. Variable power supply. And okay, so the meter is working, and the LED, I guess it's an LED. It's a neon. Can't really see that thing. That little red light kind of blocked my that. So we've got power, and we've got some voltage here. Now what I want to see, which thing is a discharge resistor, aren't. Okay, so I've got voltmeter right there. I'm going to put this probes in here if they'll go. I'll check AC volts in a minute too, see what we're at there. Okay, so this is 8 volts. What is this? 2? Okay, I already tell you that the needle is off. It's 10 volts and it's reading 19. So I think what we need to do is probably adjust this little dude here. Can I even adjust that? Is that adjustable? You know, I bet it's because of the there's no way. That's 7 volts right there, and I ain't supposed to be doing that. This is doing nothing really. It's not really doing much, is it? Well, I wonder if I throw a load on. So I'm going to put it in the 20 amp DC. How many amps we got going? Okay, there's an amp. So the ammeter is almost right. This is really strange. What does this do? Okay, I see what this is doing. This potentiometer here is changing the ammeter. So the ammeter is about right. So what's the volts not? Goes back over here. Back over to 200. Well, it says 5, it's 8, but I guess if you put it on a load, it'll drop. I could test it. I could actually test that, I think. No, I can't do it with that. Do I have a wire with a... Yes. Get a couple of alligator clip type wires here and a battery and see what happens here. Take that off. Get in there. I don't expect these things to be perfect by any stretch of the imagination, but a ballpark figure would be nice, you know. And here's a little battery here. So I got voltage. So 16 volts, that's a little high. 14.4 is about the charging voltage of, what did we say? 14.5, 14.9 charging voltage. And we've gone down to 12. So this battery's got 12.8 on it. Fortunately, the meter isn't showing 12. This meter is not very accurate, I've noticed. 30 amps. So this battery is charged, not even pulling any load. Anyway, meter's not very accurate. I wonder if this wire up here has got something to do with that. I don't see why it would. That potentiometer may have something to do with it. I've got some, where did it go? Some contact cleaning solution. I have this stuff here I can always squirt in there. That might help it. Not sure. I'm not really sure what's going on here with this. Yeah, it's not even affecting the voltage. It could be the capacitor. I would change that capacitor. That may have driven it up a little more. How interesting. Yeah, it seems to be just fine. I'm going to check for AC. And to check for AC on these, excuse me, you check for AC on here, you just put it in AC 200, and you see I still got it there. So I'm at about 15 volts. I'll go down to like 12 point, this voltage here, and then go to there, and it's 12.7 DC, and it will balance out to a negligible 0.1 on the AC. That if you have voltage of a significant value, like 1, 2, 3 volts coming on your AC here, that means you've got capacitor problems, and that's where your hum comes from. And that's what I was getting with this this paper cap here. Now this, I don't know, I'm gonna throw it in the garbage, but that is about done with this particular power supply. And this video is long, man, 40 minutes just on the second part after the battery died on my camera. So the Welch Scientific Company variable power supply, this machine here has I guess successfully been repaired. Now it's all just cosmetic from here, like the case. Of course I gotta mash all these wires down for the case back on. Case, I might go and paint it. I can paint it black if I can get the handle off. I gotta be able to get this handle off somehow, or just tape it all up. I gotta try to paint that, make it look a little nicer. But until then, I may or may not make a video on that, and I still gotta find some feet for this. I haven't found any yet. I got a box of feet come off other equipment, and I'll see if I can find some. But for right now, I'm going to leave the video here because this is going on over an hour. I'm going to leave it. Oh, I didn't check the AC power, did I? I'll check the AC power right quick. It's not too trivial. I'll check the AC. AC should be fine. So we're already set to AC, and we'll just ram these in here. We'll kick it on. And 11 volts, variable. Well, maybe the meter. Oh, I see. DC meter. No, it's not doing it. I'm thinking that maybe something's wrong here. Maybe that resistor's open. Anyway, the AC is working. I have to figure out why the meter is off, but the AC seems to be... Well, the AC volts are kind of off too. Huh. Can I adjust the AC volts? No. So I'm just going to chalk it up to the capacitor is what's changed the voltage, of course. It's higher capacitance, higher voltage capacitor. Should provide years of service. So yeah, this video's done. AC DC now works. There appears to be no AC on the DC side, which in theory means no ripple. So this would be good for bench use. I'm going to take my brush after I turn this off, kind of clean all this up a little bit, and see about painting the case. And 250 ohms at 10 amps is a resistor here that may be bad. I don't think it's bad. I don't know. But anyway, I'm gonna go. I'm Elf Company Game. If you like the video, be sure to leave a comment below. If you like it, leave a thumbs up, subscribe, all that stuff. You know how it works. And I will see you guys in the next video.